Hi guys, today we're going to go over the properties of exponents. I'm just going to give you kind of a general overview of the different properties that they have, and I'm going to go over some example problems with you that is included with this kind of chart that I have. So yeah, here we go.
So here we just have a general breakdown of exponents. You guys should know kind of just the general rules of exponents already. If you don't, I would recommend going to any of the other videos on this webpage that can kind of help you out with that. But here's just a basic overlook. Whenever a number is being raised to the power of another number, it's just being multiplied by itself that number of times. So the example we have here is 3 to the first power, same thing as saying 3 just by itself. 3 to the second power is the same thing as saying 3 times 3, which is 9. And then we go all the way up to 3 to the fifth power, which is the same thing as saying 3 times itself 5 times. So that's just kind of the broad general overview of how exponents really work. So first we have the property of 1 here, which is that any number raised to the power of 1 is the same thing as saying itself. So the example I give here is 5 raised to the first power equals 5. So the easiest way to look at it is every number is already raised to the first power. So any number you can think of just on its own, as long as it is that number, is raised to the first power. Moving on to the property of 0, if any number is raised to the power of 0, it equals 1. So the example they use here is 7 to the 0th power equals 1. So that's just a clear explanation for that. So any number whatsoever, as long as it's raised to the 0 power, equals 1. Now we look at the property of negatives. So whenever a number is raised to a negative exponent, that's the same thing as saying it is 1 over that whole entire number raised to that exponent. So the example they give here is 4 to the negative 2 power is the same thing as saying 1 over 4 squared, which equals 1 over 16. So whenever you see a negative sign next to an exponent, that just means that you're going to have to take the inverse of the whole entire kind of equation there, and then as whenever you have the number in the exponent in the denominator, the exponent becomes positive. Moving on to the product property of exponents, we have here that a to the m times a to the n equals a to the m plus n. So it's saying whenever you have an integer, or whenever you have a number raised to a different exponent being multiplied by the same number with a different exponent, it's the same thing as saying that number with those two exponents being added together is what it's being raised to. So the example they give is 3 squared multiplied by 3 to the 4th power equals 3 to the 2 plus 4th power, which is 6, so 3 to the 6th power. Now looking at the power of a power property, we have a number being raised to an exponent, and then that whole entire thing being raised to another exponent. So we have a to the m in parentheses being raised to the n, and that's the same thing as saying a to the m multiplied by n. So the example they give is 2x squared y cubed. So that's the same thing as saying so that's the same thing as saying 8x to the 6th y to the cube. So you're multiplying that x squared by or you're multiplying the exponent that x is being raised to by 3. So that's why you get 8x to the 6th. You're just cubing 2, so you get that 8. And then you're just cubing y, so that's why you have that y cubed at the end there. Moving on to the power of a quotient, we have so a fraction here being raised to an exponent. So we have a over b being raised to m. And so the way you can understand that is it's a being raised to the m over b being raised to the m. So it's just both of those numbers being raised to the same exponent. And the example they give is x over 3y squared raised to the 4th. So that's the same thing as saying x to the 4th because x is being raised to that exponent. And then we have 3y squared being raised to the 4th. So we'd use the power of a power rule on that. So it would just be 81y raised to the 8th. Now we have the power of a product rule, which is two numbers being multiplied together being raised to the same exponent. So that's the same thing as breaking them up into the two different numbers being raised to their same exponent. So the example they give is 3xy cubed raised to the 2nd power. So that's the same thing as you could break that up into two different a and b there. So you have 3x being the a and then y cubed being that b. And then so you just raise those each to their own individual property or exponents. So we have 3x being raised to the second power, which is the same thing as saying 9x squared. And then we have y cubed being raised to the second power, which is the same thing as using the power of a product rule. So we're just multiplying 2 by 3, and then we get y to the sixth power. The final property we have is the quotient property. So that's an integer being raised to an exponent and over another one being raised to a different exponent. So that's the same thing as having those two exponents being subtracted by each other. So the example they give is x to the fifth over x squared. And so that's the same thing as x cubed because you're subtracting 5 or 2 from 5. So 5 minus 2, and then you get 3. For the second example they give, we have x cubed over x to the ninth. You're simply just subtracting 9 from 3, which is 6 or negative 6. So you're going to have 1 over x to the sixth because they're using that that property of negatives rule that we have above, where whenever it's being raised to a negative exponent, it's the same thing as saying 1 over that number being raised to the same positive exponent.
Okay, guys, so that's what I have for you on properties of exponents. I think these are super useful whenever you do math, and it's something that you're going to have to use for probably the remainder of your life, so it's a good thing to learn it now. All right, so I'll see you guys in the next video.